Hi everyone, today I want to share our latest update for our Ollama K80 Home Lab project. It's 2025, almost 2026. People often ask, why keep using such old, slow hardware? Even CPU might be faster than the GPU. The reason is simple. By running Ollama on Nvidia K80 GPU, we learn and grow. We build better skills in engineering, app development, and workflow automation. Without this hands-on work, you would never learn things like how to compile a kernel, how to install GCC, what end-of-life means for software, why a kernel don't support certain hardware, how to switch GCC versions, and much more. Today I want to cover two topics: our Docker build system, modern AI CI/CD workflows, and some recent limitations we have found. This Docker build system uses a two-stage to build and run Ollama 3.7. The builder image uses Rocky Linux A, CUDA 11.4 Toolkit, GCC 10, CMake 4.0, Go, Golang 1.25.3. These versions are critical. They form a very tight dependency chain. You might wonder why not use the default GCC 8.5 in Rocky A or GCC 11.4 in Rocky 9. The problem is that these versions cause issues when installing the CUDA Toolkit. Even when compile Ollama's C code, you will run into different compile error. The CMake version also matter a lot. Only certain versions work correctly with Ollama 3.7. If something breaks in this chain, the fix becomes painful. You might need to change your GCC version, then recompile the kernel to install the 470 driver, then debug the code again. Nothing works, and your system becomes a mess. To avoid this, I create a makefile that uses the builder container to compile the binary. I also hard-coded the path for some libraries and export them directly. This keeps things stable. The trade-off, we end up with a very large runtime image. For now, that's an acceptable cost for the stability. Let me introduce the CI/CD infrastructure and the test framework we use to validate Ollama 3.7. I set up a self-host GitHub runner for GitHub Actions. This worker node runs locally on my machine, so it's free to use. Using a workflow file, I create a test framework that can build and test code. Of course, this requires a K80 GPU to be attached. The framework using two types of judge to verify test result. Simple judge based on exit code, pattern matching, and the second one is LLM Judge, a smarter verification method that uses a language model to analyze test log. The judge receives the test criteria and the logs, then decide if the actual behavior match what we expected. For the LLM Judge, we use Ollama 3.7 running the Gemma 3 12B model. Let's run the full test pipeline. We run from the main line and test judge mode, select dual. The LLM model for judging using the Gemma 3 12B. Of course, it running on our GitHub Actions self-host runner. So the log will send to the Ollama 3.7 and so in the GitHub Actions host, I spin up a stable version of Ollama 3.7, then use it to judge the result, the log. So the test target will provide the log to the stable version of Ollama 3.7. So this is a modern AI CI/CD workflow from the build to check the container and the runtime, then testing the inference, even test the model, different model. Let's take a look the log. You can see we can using different tests to verify the builder image. So builder image exists, and this one is the compile. So compile is complete. Here is the result. So the execution log will send to the LLM Judge. LLM Judge will using the Gemma 3 12B to check the log, and the output will be JSON format. So here is the modern log architecture, so you can easily get information from the JSON object. Here is total 2 test case, and the 2 is passed, 0 fail. So there are 2 different judge. Simple judge say it has 2 passed. LLM Judge also say it's 2 passed. We are running 2 test cases. Here is the result. So the builder image verification, true. So here is the builder image. So we confirm we have the builder and the toolkit installed. GCC version is correct, and the Go version is correct. So all step is correct. Here is the LLM Judge. LLM Judge also say the all Bluetooth and successfully verified. Okay. Here is the compile image build. Here is the command. So using the makefile system, you can see here cd to the Docker, and here is environment variable. I used to provide the Ollama version. The current version is the 2.1. And here is the build runtime command. You can use this command in your host also if you clone the repository to your machine, and you install the driver container runtime, and you can using the Docker build. You also can build the builder image by yourself. So here is the compile runtime log here. As you can see, it takes about 19 seconds because it is cached. If using no cache, it will take about 18 minutes in my host. Okay. So the modern CI/CD architecture will capture all log and output a structure in a very clear structure. You can see everything important. So the output image is about 30 gigabyte, very large. So after check, the LLM Judge and the simple judge also say it's passed. Then the runner will upload build result to the GitHub. Okay. You can see the runtime test is passed. We are running the inference test. The inference test we running a Gemma 3.4b, and test choosing the Gemma 3.4b because I want a simple test while the runtime is built. So every time I change the code, I can using the inference test. In here, I have to mention a limitation here. When the model loading, first time loading to the Docker, it take about 3 minutes the first time. So after you boot your system and the first time boot up your container, the first boot time, the load time will take about 3 minutes for every model. I still cannot find out the reason why it takes such long. Even I add a lot of debug log to the C code, I still cannot figure out why it takes so long. The most possible reason is it compile some runtime and the binary, sometimes into binary, something to binary by first time it load to your GPU, so it take a very long time. When second time you load this any model, it will be faster. For example, if you loading a 4B model, it will take about 10 seconds, not 200 seconds. Such like that. It is a current limitation here. Maybe somebody can tell me what's going wrong about this one. So here is the log. We can see here. So we're running a inference to ask the LLM tell us what is 2 plus 2. So it should respond 4. So the test is passed. Then we check the GPU memory usage. It's using about 5 gigabyte. So it actually load to the GPU. The command is the Ollama 3.7. We're running the command inside Ollama 3.7, Nvidia SMI. So here is. And we also send the log to the LLM to verify, ensure everything, not only the standard output, say, or something match or not. Let's take a look at the model test. The model test, I want to test some compatibility. For example, every time I change the code, every time I add a new support model file, so I have to ensure the previous support one, for example, the previous successful running model is still running. So I will add this test more and more model once we support new model. So this one is testing the GPT OSS 20B to ensure it still can run in the Ollama 3.7. Okay, so we running Inference and check the response and GPU memory, just like the Inference test here. So let's take a look. It's passed, and let's check this one. So it actually takes about 46 seconds to load into the VRAM and respond. So test is like that. When we running the Ollama 3.7, we send an API call to ask GPT 20B what is 2 plus 2. So it takes about 46 seconds. Because it is a very simple problem. So most of the time it will spend in the loading memory, loading model to the VRAM. So you can see here it's about 7 gigabyte. There are two outputs. So the GPT OSS will load into 2 GPU, and it takes about 7 gigabyte for each. Let's check the LLM Judge. So there is no error here, and it shows flash attention enabled but not supported by GPU, because it's a new architecture feature the K80 do not support. So here is today's demo. Demonstrate the modern CI/CD and with AI integration here. We using the K80 GPU to verify the log. Thank you for watching.